Welcome. This four-part video series is a walkthrough of the U2V methodology with focus on building optimized U2V control objects. What is a U2V control object, you ask? It is a software object built to address the control and operational requirements of a field device in a plant structure automation solution. But wait, there's more. These objects are built following the U2V golden rule. Don't make me touch the keyboard unless it's absolutely necessary. Okay, seriously. It is a Unity Pro derived function block, aka a DFB, and a smart Vijeo Graphical Object. And these are built for use again and again and again. Parts 1, 2, and 3 of this series are primarily instructional, and Part 4 is a demonstration. This is Part 1, and here I will provide some background information and basic guidelines for building the objects. Part 2 will focus on the control object, or DFB development. Part 3 on the operational object, and in this series this will be the Vijeo Cytec Genie and Super Genie. And wrapping it up in Part 4, I will take an existing U2V control object, adapt it for additional functionality, and implement the adapted object. To begin exploring the background of the U2V methodology, I will define the perspective of the approach using the infamous layers of plant operations model. At the device layer, Schneider Electric has software tools for field device configuration and management. At the process layer, a Schneider Electric plant structure solution uses Unity Pro with Modicon controllers and Vijeo Cytec. This is where the control objects reside and execute their functions. The goal of the U2V methodology and tools is not only to minimize the development time required to deliver a plant structure solution, but to also provide a system that exceeds typical system specifications and provides extended functionality without requiring additional development tasks. This is accomplished by automating the object and data linking, as well as embedding some tricks into the objects that are developed. Schneider Electric's StructureWare Process Expert System, or PES, provides this as an umbrella software solution, integrating the control and operational supervision into a single environment with a systems approach. The fundamental core of PES is the tested and validated object libraries, which when used significantly reduce the overall project execution time. StructureWare PES can be described as a top-down approach to plant structure system development. So now consider a case where there is in-house Modicon and/or Unity Pro expertise, but a lack of Vijeo Cytec experience. This may represent a case where the U2V methodology and tools could be used to accomplish the reduction of development time. With U2V, the fundamental core is Unity Pro, and a user or system-specific library of objects. U2V can be described as a bottom-up approach to plant structure system development. In addition, whether the system is for process control or for an RTU-based SCADA application, U2V supports both. So if plant structure solutions libraries or user-created libraries are used, the result is the same. There is an object-oriented system with a minimized project execution cycle. Now let's take a look at the U2V development guidelines. Object development must consider and address the needs of SCADA and local HMIs, including the protocol that will be used for communications between Vijeo Cytec and the Modicon Unity controllers. U2V is optimized for the OFS OPC and DMPR drivers of Vijeo Cytec. Objects should be platform independent if possible, meaning unrestricted use in M340, Premium, M580, and Quantum applications. Understanding the why and how of these two guidelines will be addressed in more detail in Parts 2 and 3 of this series. Lastly, the U2V golden rule. Using the objects shall require minimal keyboard input, or don't make me touch the keyboard unless it's absolutely necessary. To illustrate this, consider the typical use of a Unity DFB. A Unity project contains a DFB, or the user has put the DFB into the Unity types library. An instance of the DFB is added to the Unity project. Next, it is necessary to create the variables that are attached to the input and output pins of the DFB. This requires typing, and that is exactly what we're supposed to be avoiding. So how can we avoid this? Unity Pro has extensive and powerful export-import capabilities embedded into the software. One of the most agile is importing program sections. When Unity Pro sections are exported and then imported, two results occur in the target Unity project. First, the section logic is added, and second, all variables referenced in the imported section are added to the target project. This provides an opportunity to reduce the amount of work required when adding a DFB instance to a Unity project. Rather than simply creating a new DFB instance, if the user imports an exported section containing both an instance of the DFB and all of the required variables connected to the DFB pins, then the task of creating the variables is avoided. This defines the basis for the existence of U2V DFB template section instances. The U2V DFB Manager exploits the Unity Pro feature of program section importing and does this by generating program sections with DFB instances. Part 2 of this series will provide all of the details required for creating U2V DFBs that minimize keyboard usage. So importing program sections can minimize keyboard usage, but what about automated object linking? Well, Unity Pro has another export-import feature that can be exploited to address this one. An exported Unity Pro project contains all of these elements, and the variable section is the part that the U2V VJC Builder exploits. The Builder tool uses an exported Unity project file. It extracts the variable section and uses the custom field for each variable to generate Vijeo database content. This enables the U2V methodology to accomplish the automated object linking. Understand that the linking is also subject to the U2V golden rule. Using the object shall require minimal keyboard input, or don't make me touch that keyboard unless it's absolutely necessary. Part 3 of this series will provide all of the details required to understand and implement the automated object linking. Just a couple of final points to make in this first part of the series. The U2V methodology promotes standardization of object and variable naming conventions, program organization, programming techniques, and the user interface. This standardization will bring many benefits to an end user and can be the single deciding factor to choose this type of a solution. But keep in mind that having a standardized naming convention is key to how far the automated object linking can be leveraged, and therefore how much the project execution cycle can be reduced. Because without a standardized naming convention, you will probably have to touch the keyboard often. The U2V example content uses a standardized naming convention based on the ISA 5.1 standard and includes suffixes to identify variable usage. Following these guidelines will maximize the time saving. But these are only guidelines, and the tools can be used with just about any variable naming convention, as long as it complies with the Unity Pro variable name rules. If you will be continuing on into parts 2, 3, and 4 of this series, please take some time to review this graphic. Understanding this is fundamental to success using the U2V methodology. Don't forget that the Unity Pro companion tools are freely available for download and use by clicking on the icon on the Unity Pro Experts YouTube channel art banner, or on the About page. Thank you for your time and have a great day. Subscribe to this channel to see more demonstrations of Unity Pro tools, tips, and tricks.